Hello everybody, welcome to this video. We're going to be focusing today on how to quickly do Newton's method to approximate a root or a zero of a function if we're only able to use a scientific calculator for a calculus exam. So for example, if you are taking an online exam, you probably get to use Desmos Scientific Calculator, so that's going to be the method that I show you today. The first thing that you're going to want to do is when you get to the question on the exam, that's going to ask you to use Newton's method to approximate any real zeros close to some number. What you're going to want to do is go ahead and draw out your table so that you can quickly organize the information. So go ahead and pause the video and do that. You want to have 1, 2, 3, 4, 5, 6 columns, and then who knows how many rows it's going to be. We can always start off with 3 rows, and if it's not enough, we can add a 4th. Now, every exam question might be a little different. So for example, this question is actually telling you the starter value. So if you don't have a starter value, you would guess that. And then what you're going to want to do is you're going to want to have enough entries that when you look at this last column over here, the difference between those x values is whatever is specified by your instructor. So using Newton's method, we want to try to find a zero, which means we want the best approximation possible. So some instructors might even have this as a 1 here instead of a 5. So that's a very, very close estimation that we're wanting. So for this example, we're going to use the function x cubed minus 7x, and we'll round our final answer to 4 decimals. So once we found that zero, we'll round it to 4 decimals. So where do we start? We're going to start by filling in our table. So you could have a blank table on your paper when starting off your exam, but you're going to need to remember what are those things involved in finding Newton's method or using Newton's method. So n here is just going to represent the number of iterations that I'm going to be using with Newton's method. That's not necessarily required, but this next part is. So x sub n is going to be the very first x value that we choose, so that would be 2.2, and then this is going to be f of 2.2, and then we're going to need to take the derivative of the function and evaluate it at 2.2. And then we're going to take the quotient of those last 2 columns, so the function value divided by the value at the derivative, and then we're going to take that value and subtract it from that first x value we used to get our next x value in the next row. So let's go ahead and grab a calculator and let's do that. Our derivative here, if we drop down the power, is going to be 3x squared, right? Drop down the power, decrease the power by 1. And then the derivative of negative 7x is just negative 7. So grab your calculator. If you're using Desmos and you're able to use Desmos, please pull it up. Yes, Desmos graphing calculator is probably the quickest, but a lot of calculus students don't get a calculator at all. And if anything, they get a scientific. So that's why I'm going to demonstrate it with a scientific calculator. So we're starting off with x equal to 2.2, grabbing our calculator. So I'm at desmos.com/scientific. I'm going to type in 2.2 into my function. So 2.2 cubed minus 7x. And then I'm going to type in 2.2 into the derivative. So 3 times 2.2 squared minus 7. It's going to be 7.52. And then I need to take the quotient of those two. So negative 4.752 divided by 7.52 is some decimal number. And then I'm going to take that, and notice I'm taking the fraction form here rather than the decimal approximation. It's always better to do that. And then we're going to subtract it and we're going to get a number. What we're going to do now is we're going to round this number here and start to substitute it back everywhere you saw 2.2. That's what's making this quickly to use with Desmos. So if I catch up to my video here, okay, and then because I'm on a computer, I can copy and paste, copy and paste. And so what I'm actually doing when I'm using Desmos is I do everything on the computer first, and then I'm going to fill it in here. So if I'm catching up, okay, so then I'm going to use about 5 decimals here. So especially if I want a 4 decimal approximation here, I probably want to use 5 decimals when I substitute it in for x. Copy and paste everywhere I saw that other x value I used. So the last one will be down here. And then what you do is you are going to take this, you're going to get a quotient, right, of this divided by that. And then you're going to grab this and subtract it. So filling these in on my paper. Okay, and then copy and paste. And if you don't have the copy and paste feature, maybe because you're using Proctorio in your online class, then it's not too difficult to type it in. I feel this process is a lot better to use with Desmos rather than a hand calculator. If you are able to use a graphing calculator, of course, it's much quicker to just type all of this into the y equal feature of a graphing calculator. So again, rounding to 5 decimals for this x value, I'm going to copy and paste it into all of these places in my stored data history here, wherever I saw it. And then I'm going to go ahead and start to copy and paste into this quotient here, my 2 answers, to get this new decimal. And you see that we get some number times 10 to the negative 4. So if you saw it right here, what you do is 10 to the negative 4, it means that you'd grab that decimal between 1 and 5 and you would move it 4 places over. So that's scientific notation. And we've got our last answer, and we can stop here because of the following. If you take a look at these 2 decimals, you can see that the fourth decimal place here is a difference of, well, it looks like it's a difference of 2, but if you round those numbers to 4 places, this will be 2.6459, and this one would be 2.6458 because this 5 tells us to round it up. So that means that we're looking at the difference of our x values here, of our estimated zeros here, is a difference of 0.0001, which is an even better answer than we were hoping for. So our final answer to this question, it wanted to know what a real zero is. You could either write it as an x-intercept, so this number comma 0, or just report the x value. And congratulations, you are done with the Newton's method. So my recommendation to you is to do it quickly here, and then once you have all 4 of these entries in, then come write them all down here, and then get your round to 5 decimals, write it over here, and continue. So again, the reason we're doing 5 decimals is whatever you're looking for. So if you were looking for only 3 decimal accuracy here, you would want to round up to 4 or at least 5 decimals over here, because the more decimals you have, the more accurate your answer is. Good luck, everybody.